Hey there, welcome to my channel. Today we have an exciting tutorial for you. I will be diving into the world of serverless development and exploring a new framework known as SST. So, in this video, we will be seeing about SST, how is it different from the previous framework that we have seen, that is the serverless framework, how we can get started, perform some live debugging, and the conclusion. So before we get started, if you are new here, don't forget to hit that subscribe button and ring the notification bell so that you never miss an update. So now let's jump into it. So here's what we will be covering in this tutorial. We will be looking into what is SST, how is it different from serverless framework, how do we set up the development environment, build the REST APIs, deploy the APIs to AWS, and finally look into live debugging with SST. So, what is SST? Now, SST is a modern full stack application framework on AWS. It is a framework for building serverless applications on AWS using various AWS services like Lambda, API Gateway, event-driven services, etc. using AWS CDK. It simplifies your development and deployment process, allowing you to focus on your code rather than infrastructure. In all my previous videos, we saw about building different kinds of applications using serverless YAML. So, why a new framework like SST? So, SST does offer new capabilities over serverless framework. So, let's go through it. So, here is a nice link from SST which outlines the differences between serverless framework versus themselves. Right? Now, serverless framework was launched way back in 2015 and it's far and away the most popular way to build serverless applications. It uses this serverless.yaml file to define your infrastructure. Now, this YAML file gets converted into CloudFormation template, which eventually gets deployed to AWS. However, for any other given infrastructure, you will need to define it directly in CloudFormation. With SST, it uses more of AWS CDK to define your infrastructure. Hence, you could use or define the stacks using programming languages like JavaScript or TypeScript. SST was launched in early 2021 and is being grown rapidly to become one of the newest way to build full stack serverless applications. Here are some of the comparison between serverless framework and SST. One of the major differences between those two is that in serverless framework, you need to define your configuration and infrastructure using CloudFormation, but whereas in SST, you can use the CDK, that is the Cloud Development Kit, in order to define your infrastructure. Since you are using real programming languages to define your infrastructure, it's way easy to build reusable assets within SST and reuse among your different code projects within your organization. With serverless framework, in case you want to get with the local development, then you need to rely on something known as serverless offline or mock those services. And in order to test, you would have to redeploy the changes repeatedly. Whereas in SST, it provides a technique known as live Lambda development, which we will be seeing in this video in the later half. Also, it allows you to perform debugging, like how would you do with any other application development, that is by using breakpoints, etc. There is lot of flexibility, especially when you are using SST. As we saw that we are using CDK underlying, so there are different kinds of constructs that are being made available. Okay, so this is in nutshell what is SST and how it compares with serverless framework. In our second section, we will be looking into setting up the development environment. In order to set up the development environment, we will need Node.js, AWS CLI, and the SST package itself. I'll walk you through the installation process step by step in few minutes. In the third section, we will be looking into how we can build a REST API with SST. With our environment being set up, we will be building REST API, creating endpoints, defining functions, and then use AWS CDK in order to configure the resources. I will write some code and explain each step along the way. Post development of this REST API, we will be deploying it to AWS. We will use the SST deployment commands to package and deploy our serverless application. This is where all the magic happens, and we will see this in action when we do the demo. And the last section, which is one of the major capabilities of SST, is the live debugging. What if something goes wrong? You need not worry, because SST have you covered with the live debugging. So I'll show you how to set up debugging sessions and troubleshoot any issues in real time. Now, let's put everything into action and write some code to build the REST API. So the first thing what you need to have is Node.js and the AWS CLI configured. Once you have the AWS CLI installed, what you can do is navigate to the documentation on the SST dev and go through setting up AWS. This page defines all the steps that you need to do in order to configure your AWS CLI to talk to your AWS account. Okay, so what we will do is I will go to my terminal here and I will do an AWS SSL login. So I'm using the organization concept exactly how it is mentioned within the SST documentation, and I have a session being configured with AWS. Okay, so I'll just go through this process. Login. So what this will do is this will configure our AWS CLI. Okay, as we can see here, I have my AWS CLI being set up. Okay, so the next step is we will need to install or initialize our SST framework. For that, we will be using the command. So what we will do is we will need to use this npx create SST, which uses the template base example, and the name of our project will be tasks API. So we will go to our terminal, paste this command. What this command will do is it will install the necessary packages, and create a project from the template that we have defined here. So base/example is a template that is made available by SST. So we will go inside the task API and we can do the normal command like npm install, pnpm, whatever you want to use. So I will use npm install. So this may take some time because it needs to bring in a lot of packages that are needed in order to simplify our development. So while this continues, I will pause this video. Okay, so we have the npm install being done. So what we will do is we will open this up in our code editor. So as you can see here, we have the basic structure for the code being outlined. So it uses TypeScript by default. It has the tsconfig.json, which is defined. It has this file called sstconfig. This is basically the place which brings in all the stacks together and configures it. The most important part are a couple of things here. One is under the packages, we have two folders being defined. One is the core and other is the functions. The idea here is that you define all your function and within this functions folder and all the core operations or functionalities in the core folder. All of this is integrated or made available using the workspaces option. If you notice within the package.json, you will see that it has certain dev dependencies which uses the SST, the CDK, TypeScript, etc. And within the scripts, you have some basic scripts that will help you to do the local development as well as to do the deployment. We have this workspaces concept. So this packages everything within this packages folder. So without wasting much time, let's get started. So what we will do first is under the stacks, we have this example stack.ts. So this is where we need to define exactly the infrastructure that we want for our project. So in this example, what we are trying to do is build a REST API. So we will need an API to be defined, which would bring in certain functions on different endpoints that we have, like let's say get all, get, etc. So we will not build anything concrete here like a CRUD API because that remains same as to what we have done with our previous examples. The main aim here is to understand how we can build, how we can make use of these two folders, that is core functions, how we can deploy and go about the live debugging. So first thing what I always do once I initialize the template is rename this stack. So what we will do is we will rename this and call it, let's say, API stack rather than example stack. Okay. So once we have done that, the other important thing that I always do is go to the SST config, and within this config section here, go and change the region if that's not the region that you wish your code to be deployed in. In my case, I want to deploy the code in the AP South 1 region. Now, since we are using TypeScript and programming language here, you can use different kinds of packages, libraries like .env, bring it here, use environment variables, etc. So we will see in details in the upcoming videos on the advanced examples using SST, but for this video, we will keep it very simple. This another option that I would want to add here is the profile, because I have multiple profiles being defined within my system. So here I want to use a profile called AWS-CB. Okay, so this is basically where I need to specify the configuration. So next step, what we will do is go and create our functions. So let's say I have two endpoints to be developed. One is get all nodes and one is get a specific node. Okay, so basically I'll need to create two files, which I usually prefer. So what we will do is within this function, create a new folder called src, and within the src, let's call getAll.ts, and let's say get task.ts. Okay, so let's have this as get all tasks so that it's very much clear. Okay, so we will go ahead and write this function in some time. Before that, let's go and define our stack. So in this stack, what we need to do is on this stack, we need to basically add our constructs. So what we will do is we will create a new API stack. Okay, so if you see, we will call the API from SST constructs. Okay, this takes in the scope, that is the construct, that is the stack itself, and the next part is the props along with the ID. So let's say the ID is API and the third section is the props. Now within this props, we can define our function. Those functions are nothing but routes first, so we'll have to define the routes. So let's say we have a route called get, and let's call it tasks. So we want whenever someone hits /task get endpoint, we want it to invoke a function that is defined in packages, functions, src, and then we have get all tasks dot, I'll put handler. This handler will be a method that is exported from our get all tasks.ts. The other endpoint that we would want is the get task by ID. So what I will do is I will use get task and it will take a parameter called ID. So this ID we can dynamically reference within our get task.ts. So what we will do is when someone hits this endpoint, we want this function, that is get task, to be invoked. Okay, so we will see more in detail about how we can configure certain configurations for this function, like setting up the runtime, the log retention, architecture, memory size, etc. So there are a couple of ways. One is either we can have those values being made available as a default props to the function, or if you want to override it for a specific part, then what we can do is instead of passing this location as a string here, we can use object, and within that object what we can do is we can specify different properties. So we will see that. So what we will do first is let's try to set some kind of a default function, that is a default props for our function. That is, for all these functions or the endpoints that we have defined, we want certain values to be set as default. So for that, what we will do is we will call set default function props on the stack object, and this on this what we will do is we will set certain memory size, etc. So let's say I want 128 MB to be the default memory size. I want the architecture to be ARM64, that is using the Graviton. Let's say my runtime is Node, so you can select here Node.js 18.x. See, this is the advantage of using real programming languages, right? So it gives us a good autocomplete or suggestions. that can aid development. And let's say the last one, what we want to do is log retention. I don't want this to be saved for a long time since this is just for demo purpose. So I'll just select log retention equal to 1 day. Now let's say I want to override few of these things for our given function. Then what you could do here is, instead of passing this as a string, we could rather use an object, and you could define like type is, you see, different stuff. So it is a function for us. Then let's say for the given function we want to override some kind of a name. So I can have function name, and the function name could be, let's say, get task by ID. So basically I'm providing some additional parameters. The handler is basically the location which will get executed, the code that will execute it. So this was get task dot handler. Similarly, you would have a lot of things that you can basically override, like the architecture, the memory limit, the disk size, environment variable, storage size, layers, etc., etc. Okay, so we will keep it damn simple here. So let's not do anything more. Now this is our API. Okay, so what we could do next is we need to add or display some kind of an output, right? So for that, what we will do is, within the stack, there is an option called add outputs, and within the outputs on the console we want to define or show the API endpoint. So for each of these objects, since this is API, this will return some kind of an output. So one of those which we are interested basically is, you see, API.url. So what this will do is, once we deploy on the console, it will show us the API endpoint, which we can use to invoke our function. Now, since we have the definition defined, that is the infrastructure defined, let's go ahead and implement these two functions. Okay, so first let's go ahead and implement get all tasks. Now, before we implement get all tasks, we need to have tasks defined somewhere. Like, so basically we would be using databases in order to retrieve or store this information. But in this case, what we will do is we will just have certain tasks being created in memory and use that within our functions. So all those core functionalities should go into the core folder. So that's basically the convention. It's not a hard fork rule, but that's basically the convention. So what we will do is, within this core, we will create a folder called src, and let's say we call task.ts. Okay, so here what we will do is we'll simply create an object. Let's say it is of record number colon any. So basically the key will be a number and the value could be anything. Okay, and within here we will have, let's say, task1 is an object, and it has, let's say, something called name for the task, YouTube video for SST. Let's say we have some kind of a user ID, which in my case I'll just put some kind of one. I'll say content lorem ipsum whatever, and let's say another field called created yet. I will use date dot now. Okay, so something like this. And similarly, I'll just, what I will do is I will just duplicate this and create my second task. Okay, so this is task 2. Task 2 content goes here. So just let me make some kind of, let's say this is 10. Okay, so basically I have, let's say, 2 tasks made available here. So now within the get all task, let's try to implement our function. Okay, so the first thing, as we saw that we were using get task dot handler, so we need to export a handler. Okay, so this handler, let's say, is an async function, okay, which takes in an event. The event is of type API gateway proxy event. We will be using version 2 because that's the latest, and this would basically return a promise which is of type API gateway proxy result v2. Okay, so what we will do is, first let's just log something. Let's say in get all task function, and we will also just print the event. Okay, the next part is we will return. So the return should be of this type, that is proxy result. So that has a status code which will be 200, and the body needs to be in a string form. So what we will do is we will do json.stringify, and we will just return the object that we had defined within the task.ts. Okay, so what we will do is, what was the name? Okay, so we did not export this. So what we'll do is we will just export this task so that it is made available and it's available for someone to call it. Okay, so we will use task from the core SRC. So what we could basically do here is, rather than using this kind of a option, we could use the alias. Okay, because it is using this workspaces concept, so we could make use of that. So what we will do basically is, here we will make import task from task API core slash task. Okay, and we will use this task. So basically we don't need to give that relative path. We could make use of this kind of a syntax, because task API and these are the packages. Within the packages we have core and we have task.ts, right? So this src, etc. Okay, so we have this, so we are good with this method. Similarly, what we will do is we will define our get task also. Now the difference here in get task is that we need to return a specific task based on the ID that is dynamic in nature and is part of the endpoint. So in order to do that, what we can do is we can make use of path parameters. So what we will do is we will get the ID from the event. There is something called path parameters, and let's get the ID. If the ID is there, we need to return that. If not, we need to return, let's say 404, that is not found. Okay, or invalid request, whatever we want. So what we could do is, if we have the ID, right, we would want it to return, that is task, and I need to pass the ID to that. Okay, so what it says, any because is not a number. So okay, so this is a string, right? So this is basically whatever comes here is a string. Okay, so we'll need to convert it into a number. Okay, so what we could do is here we could do parse int and we could pass the ID. Okay, if it is not there, we would want to return a status code of 404 and let's say the body as invalid task not found. Okay, so basically we have our two functions being defined here. So now let's get and deploy this. So in order to deploy, we can directly make use of the SST deploy command and pass in the stage. Now this stage could be dev, prod, test, etc. So it helps us to isolate the code and the deployment across environments. So let's first deploy and then we will look into how we can do local development using the live debugging. Okay, so the first thing what I will do is I'll open the terminal. Okay, so get all.ts. Okay, I think this is from before, right? So yeah, we had made this change. Okay, so let's go to the terminal. Okay, and what we will do is we will do npm, we'll do npx sst deploy and let's say -- stage, and we want this to be known as dev. So once we fire up this command, you will notice that it will build and then it will basically, what do you say, create all those necessary resources implicitly, right? So this is exactly where the magic happens. So we have not defined or this kind of log group, the parameters or etc. So what this SST framework does is, based on the constructs that we have provided here, it implicitly creates the necessary cloud formation and then invokes it so that all those resources get created. Okay, so as you can see here, it's creating the necessary functions. So while this takes place, what we will do is we will go back to our browser and we will go to our account. So basically we connected to this AWS CB profile. So if we go here, we should be able to see certain resources being created for us. So let's say we go to Lambda. I'm within the Mumbai region, that is AP South 1, and you can see here the different functions are being created, right? So these are the two functions that SST deploys in order to manage the resources, and these are basically the one that got created because of the construct that we just defined. Okay, so let's go back to our VS Code. As you can see here, the deployment is complete. Now the reason why this shows example stack is because we did change the API stack name here, but our function was still example stack, right? So that's the reason it shows example stacks. So no worries. So basically we have our functions and the APIs deployed. You see that all the permissions etc is already taken care. So in order to test this out now, what we can do is we can copy this endpoint URL. So if you can notice, this API endpoint is basically the outputs that we had defined here, right? So what we will do is we will copy this, we will go to our browser, and since this is a get call, what I can do is I can basically make a call directly, and you can see that we have this task being the output being displayed on the browser. Similarly, if I make use of some kind of what do you say, you see there is some issue, right? So we will see why this issue is, right? So if you see 1, then we get 1. If we press 2, we get 2. But if we put something which is outside of what we have defined, we get blank. Let's try to inspect here and see what happens. So you see that it's still showing 200. Okay, but there is absolutely no response because we don't have those IDs. Okay, so let's try to figure this out using live debugging. Okay, so that's exactly where we will look into the live debugging capabilities of SST. So we go back. So what we will do is within the generated template, you see there is .vs code and there is a launch.json pre-built for you. So in order to test this out, what you can do is you can click on this run and debug. Under the debug SST, click on the play button. So here, since it's a local debugging that takes place, so it asks us to use our personal stage. So it will use our current user, whatever we have, that is Durgadas. So that's okay. So we'll go ahead with that. So what this will do is, this will create a new personal stage and it will create the debugger session with that stage. Okay, so that we can make changes, push, get our stuff working, and once we are ready, we can deploy it to the respective stage that we are interested in. That would be dev in our case. Okay, so let's wait for this to happen. Okay, so the first time it will take time because it needs to create all these resources, but subsequent tries will be much faster. Okay, so there seems to be some kind of an error here. It says that get task by ID. Oh, okay. Okay, so this is because we have explicitly defined the function name. So we should have basically used some kind of stage here so that it can differentiate and the function name is different. So what we will do is we will currently remove the dev. Okay, so in order to remove the deployment, whatever we had done, we could use npx sst remove -- stage equal to the stage name. So ideally what we would do is this function name needs to be suffixed by, let's say, the environment name, and that we could pass as the environment variable and make use of it here. So just in the interest of time, what we will do is we'll just remove the dev stage, fix it in local, and then once everything is ready, what we will do is we will deploy it. Okay, so what we will do is here we will go back and click on debug SST. So this will create all these resources within our personal stage. So the personal stage was Durgadas that we used previously. So it remembers that and it will go ahead with the deployment of the resources. So let's just wait for this to complete. So this is one of those very handy functionality of SST, that is the live debugging, which you will be pretty much impressed with. So let's get into it once this deployment is complete in the personal stage. Okay, so we are almost there. Okay, so we have this endpoint being given to us. So what we will do is we will copy this endpoint and let's just make sure that it works. Okay, so sometimes what happens is the first it might not work. So if it doesn't work, just stop the debugger and start it. So what we will do next is let's go and let's try to see if we can set a debug point and execute it. So let's say I go to the get task.ts and I'll put a debug point. Okay. So somehow the debug point is not being set. You see, it could not be set. If you are having issue, you can troubleshoot your launch configuration. So what we will do is we'll just restart our debugger. Okay. And let's try. This is one of those things I have noticed sometimes that we do get issue. Okay, but let's try if it does work. Okay, so I'll go to tasks and let's say use one. Okay, we do get the output, but you will see that we don't have the debugger. Okay, so basically here we should have got our debugger. So I think now we have the source map. So let's go ahead and execute this again. Now when we refresh, you see we have got into the breakpoint that we had set. Okay, so if the first time it doesn't, it will retrieve the source map. So the subsequent tries, you will be able to put the breakpoints there. Now, as you can see, the parameter ID is, you can see here, I can go step by step. We have different methods like step over, step into, step out. So what I will do is I'll click on step over. It goes to the next one. The ID that is retrieved is 1. As you can see, it is a string because anything that comes within the event object is a string. It doesn't identify number, etc. So if you are interested in number, you'll have to convert it into a specific data type that you are requested in or you are interested in. Okay, now if the ID is 1, then what it will do is basically if there is a ID present, it will go inside, else it will return 404, which is wrong, right? Basically, because task not found should be basically be returned if that specific key is not present within that task object, right? So if it is there, then what we need to do basically is we need to check, right? So there will be two parts. We'll say if it is not there, we'll say invalid request, and this would be a bad request basically. And let's say if the ID is present, and if that ID is not present within the task, then we want to return basically the task ID, right? So what we will do here is we'll create a task ID. I'll make it parse int ID, right? So what we need to see is if this task ID is present within the task object. So correct. So what we could do is we could say const task. Okay, and let's say task. Okay, and let's say the task ID. And then if we have the task, we will return, else let's say we return 404 not found. Okay, so I will just execute this and restart. Basically, you don't need to restart too because it hot deploys it. So we will see that. Okay, now we have this asset being deployed. Okay, so let's go ahead and okay, so we should basically be having the breakpoint now. So let's say 3. We are here. So we will step into, so ID is 3, that is correct. So task ID, if it is there, what we will do basically is okay, it has gone inside because it's not present, and it will return 404. Okay, so basically if you go back, it says not found, free, and the header is 404. If we pass in 2, then you see this will probably, you could do the step into, it will go into the right block and it will return the task that we are interested in. Perfect, right? So basically here what we could do is we could still make use of task ID. Now the interesting thing what I want to show here is, let's say the moment you make a change, you no need to deploy, right? So what you could say is, let's say we change this message saying that task with ID right, we say task ID not found, right? So basically we are changing the error message here, we are just saving it, and see the magic, right? We are not redeploying. So we just go here, let's say task 3 which is not there, and I press enter, you see task with ID 3 not found. So this is exactly how the live debugging works. So you don't need to redeploy stuff. It's basically like how you would make or work with your normal Node.js development, where you use nodemon to constantly look for your files being changed and then hot deploy it. So the same technique works here. So it makes use of the IoT service behind the scenes in order to communicate between your client system versus the infrastructure on the AWS end. Okay, so now since we are happy that it is working well, so what we could do is we could just deploy it using the npx SST deploy command, right? So now here, since I am in my personal stage, what I can do is I can do SST remove. Okay, that is the npx SST remove. Now since I have not supplied on the stage, what it will do is it will take the personal stage which is there, which we had used for the local, what do you say, for the local development, right? So if you wanted to deploy it in prod or dev, you could just use the npx SST deploy -- stage along with the stage name. Okay, so basically you saw here like how we could write, implement and deploy a REST API and also do live debugging. Okay, so there you have it. So we have successfully built a REST API using the SST framework, deployed it to AWS, and also did some live debugging for the scenario where we did not have the task in our database that was in memory. So as you can see, serverless development was never been easier, and with SST it has been an icing on the cake, right? So it's very easy to work with it. So yeah, so that's all I wanted to share in this video. Thank you for joining me in this tutorial. If you found it helpful, please give it a thumbs up and share it with your fellow friends. If you have any questions or want to see more tutorials like this, leave a comment down below. Until next time, happy coding.